Hey, what's up, guys? It's Akshay from AS Learning, and today in this video, we'll be seeing about clinical NLP. So, so everyone knows what NLP is. It stands for Natural Language Processing, and we take into consideration the interactions we have with machines and the way we humans interact. So, all this textual data or speech data is analyzed. Various models are built, and insights are found out of these data. Lots of ML activities like translation, summarization, and all those things is covered into natural language processing. Now, clinical NLP is a subset of NLP which focuses on healthcare domain. Majorly in this world, we have domains like finance is one domain, then e-commerce is another domain, healthcare is another domain, then media entertainment is another domain. So similarly, NLP focusing on healthcare is clinical NLP. It's a specialization of NLP that allows computer to understand the rich meaning that lies behind a doctor's written analysis of a patient. So any area in healthcare where NLP, where there is textual data and speech data, you can apply clinical NLP concepts there. Okay, so in healthcare domain, if you have textual and speech data, okay, clinical NLP can be applied, and uh, it's a subset of NLP focusing on the clinical data. And majorly this data is nothing but doctors written prescriptions, then the medical history of patient, so the written prescriptions, then his analysis, then if there's, let's say, then is any surgery being done, so the short summary of the surgery. So such kind of things, the data is maintained and stored, okay, as per the laws in US and India, and then different analysis on this data is the study of clinical NLP. uh, in general, the normal NLP engines use large corpora of text, usually books or other written documents, to determine how language is constructed and how grammar is formed. That is how, in general, NLP tasks are done. We take a lot of text, okay, we study them, or we label them, and then we create models on it. So it's a very a lengthy thing and a lengthy task. So it has been shortened up. Okay, people have built libraries focusing on specifically on clinical NLP, so you don't need to do this boilerplate kind of activity which is done while building an NLP model from scratch. Okay, so that is where libraries like medspacy, which is another subset library of spacy, we can say. Okay, it gets very easily integrated in the spacy pipeline, and that is how it can be used for clinical NLP. Okay, now what exactly are the major things into clinical NLP? One is entity extraction. Okay, you extract the clinical concepts which are treated as entity from the unstructured data. That's our textual data. Okay, so I'll give you an example. Clinical entities like type of disease. Okay, type of disease, then let's say patient's age, okay, patient's name. So these can be the entities extracted. Okay, next is contextualization. Okay, we try to decipher what the doctor really meant when he wrote something. Okay, let's say when a doctor says that seeing a patient's history, if he denies or accepts any condition, so that is something which the model should understand. Okay, uh, this is what the patient's history is, and he's denying some treatments or accepting some facts about the patient. So let's say, for example, if the doctor says that we cannot go ahead with the surgery because the patient's age is very much. So generally, if you know that the our 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 grandpas and grandmas who age like 80s and 90s, doctor don't recommend them surgery. So this context should be understand by our clinical NLP model that okay fine, because of age the doctor is denying the surgery. So your surgery can be the entity and age will be another entity, and you're finding that contextualization between these two things is something which will be covered into contextualization. The next is knowledge graph. Okay, now let's try to understand how knowledge graph would be helpful here. If you show a doctor's prescription to another doctor, he would understand it very well. Okay, but a normal patient cannot understand. If you show that doctor's prescription to a pharmacist, he will understand it very well. How? Because these guys understand that script. Okay, they have that knowledge of understanding the script, and knowledge is being shared by them. So in this way a knowledge graph kind of a thing is there, in which the things are there's a connection here. Okay, the similar thing which we can do implementing knowledge graph here. Okay, and let's say if a model is being studying the doctor's written prescription of few doctors, okay, he should make sense from the other doctor's prescription as well. So in this way, the clinical concepts are interrelated, like the fact that fentanyl and hydrocodone are optates. So in this way, there are a lot of medical terms, okay, which are interrelated with each other, and here the graph theory concepts comes into handy. Okay. So this was in short what clinical NLP is, what are the major concepts in clinical NLP, and how it is different and similar to the NLP concepts and the general NLP practices done. Okay, now here what we'll be trying to do is I have taken into for example purpose I've installed medspacy. Okay, and I'll be taking a doctor's written prescription, and I'll be showing you the different analysis which can be done using the medspacy library. Okay, so implementation of clinical NLP you can say. Okay, so before going to the explanation and running the code, so let's just explore the PyPy page of medspacy, and a huge shout out to the maintainers and the authors of medspacy. They have done a really great job. Okay, so it is used for clinical NLP with Spacey. Okay, it has different parameters. So these are the different classes which we have in the medspacy module. So like pre-process, which covers the pre-processing, then a sentence splitter, it takes into consideration sentence segmentation, then NER, we all know, name entity recognition. Context, finding the context is like it contains negation or uncertainty. So I'll show you this thing in the results later on. Then section detection, it also contains the clinical section detection and segmentation. So even I don't know much about this, so we have to explore this in more detail. Post process, after the entities are extracted, whatever post processing activity you have to do. Okay, visualization, this is input output. Okay, dealing with databases and all, and this is Spacey quick UML. So compatibility with the current Spacey, and uh, something with UMLS sample. So even I don't know much about this, we'll have to explore it. Okay, then I have taken the example from here only, from the PyPy, and we'll be seeing the output. Okay, so yeah, I have installed this library. The only condition you need to have is you need to have a Python version greater than or equal to 3.8. Okay, I've imported it. This is my text. Okay, you're importing a few libraries. I've imported NER and visualization. Okay, here I've loaded the model. Here I'm printing the pipe names. Okay, this is what the pipe names are. We have target matcher, context, and pyrush. Okay, this is my text, and I have loaded my pipeline. I have created some target rules. Okay, Now these target rules are my target rules for NER extractions. Okay, here I am explicitly telling that detect pneumonia as a problem, detect arterial fibrillation as a problem. Okay, if you want to add any sub parameters like different patterns and all, so you can add that also. Here a pattern of AFIB, because your atrial fib, so A from atrial and FIB from this, so in this way a pattern is added. Okay, then you can add more detailed patterns, like if you want this 2 to be 2 2, so it can be anything, not just this one, it can be 2 2 2 in this way. Then similarly for diabetes also, so you can add different patterns, and you can explore this into much depth, like how the patterns are added and all. Okay, so in this way here, after creating this target rules, I have added those target rules here using the target matcher, and after that I have ran it on my text, and then I've done a visualization. So here we can see that atrial fibrillation has been detected as problem, which we figured out here. Okay, even similarly type 2 diabetes mellitus as problem, pneumonia as a problem, if AFIB as a problem. Okay, uh, type 2 DM as a problem. Now here you can see that it was 2 years, so this 2 came handy here, then this FIB came handy here. Okay, then here it is warfarin as medication, so here there should see here warfarin as medication. And this is what I was talking about, the context of negation, which we saw here, this one, including negation and uncertainty. So here you can see that there is no evidence of pneumonia. Okay, this was the actual sentence, no evidence of pneumonia. So this is how it is coming up with the contextualization thing which I told here. Okay, it has very clearly identified that there is a negated existence. Okay, so in this way I think it's a very good work, and this can be used into production. There are many ongoing projects also. Yeah, these are some of the projects and the advances made being done with the help of medspacy. There might be another libraries for clinical and NLP as well. I came across medspacy. So if you know any another clinical NLP, or if you have built something using medspacy, do comment out. And yeah, that's it with this, guys. If you have any doubts, just ping up. For this code base, you can go to my GitHub repository. Do leave a star on my GitHub repository, it means a lot. And stay tuned to AS for more such amazing tech stuff. Take care, peace out.